Hello everyone and welcome back to another tutorial on my YouTube channel. Today we're gonna talk about breadboards. Just recently I started a new adventure mode with a friend of mine and we built this awesome hovercraft with pew pew guns. And yeah, this craft is of course player controlled, which is default for adventure mode crafts, right? You want basically only build one big craft and you want to control that by yourself, just for example like Lesric does. And yeah, what's so great about this craft is that I can adjust its altitude, for example, by pressing up and down arrows and up and down keys, I mean, and it will hold that altitude because this is PID controlled. And if I release the button, it remembers what altitude I release the button on and then tries to keep that altitude. Same goes, by the way, for yaw. So if I rotate this craft around, it will also remember this angle it's now pointing at, this direction. And if any nasty not symmetric force is applied to this craft, for example, we lose some of our propulsion back here, then we would have a force pushing us around, changing the direction we are pointing at. And yeah, let me just simulate that by adding this thruster. And you see, this craft won't get pushed around. It keeps its direction because now those thrusters right here, you see, they produce a counter force as to those thrusters here at the front, I guess. Yeah, and that's basically it. So yeah, we have something that tries to stabilize us in yawing as well, and I'm going to show you what. It's that breadboard right here, which looks very complicated, but trust me, it isn't. Believe me, it isn't, I mean. And we're going to start with this nice mass evaluator function right here. So there's some other shit going on in the background because I'm currently also in beta test, and I'm currently also figuring out how to do some other stuff. And this doesn't work yet because the new introduced custom access don't work probably yet, but that's a whole another story. So let me just show you the mass evaluator. So we basically want to save, for example, a specific altitude you want to stay at, right? This is where this little function comes into play, because we can here input three values. First of all, of course, we need our current altitude, which goes into the top as the input variable a. Then we need to check if we are currently changing our altitude. So if currently I'm pressing the up or the down button, so we have to check for the hover channel, and if the hover channel is currently used. And last but not least, we need this constant back here, which I will explain later. So what this mass evaluator does right now, can I increase its size? I can't. Okay. It checks if I did it wrong. It's like so. It checks if a is 0. A is what the first of those three inputs. This is the variable a, and if it's 0, it's gonna keep its output. This function right here, output 1, just repeats what this mass evaluator outputs, and I'm gonna show you this in an example. So I'm just gonna write output 1 plus a. So this is input a, this is the output 1. So let me put a printer on there so we can check what's the output. Currently it's 0. And now I can add something to that. And you see, it now counts up. What was happening... I have to change this, sorry. What's happening right here? It always adds 1 to the previous result. Because, as I told you, output 1 gives you the output of this first output. If I would have two outputs, so that's an input, if I would have two outputs, I could also check for output 2 with this function. But we only want one output, so output 1. So this basically just stores stuff. Yeah, it just always, in every frame, it repeats what it said in the last frame. And this happens if A is 0. So if I'm not pressing any key, it repeats its last value. And yeah, but if I'm not pressing A, then we have to read what comes behind the next commenter. And here we have another question. Here we check if A is bigger than 0 or not. If A is bigger than 0, which that means we want to go up, because A, again, is our up drive. If we want to go up, we then add B to we add B and C together. B is just our current altitude and C is just the constant 10. So right now it would output 144. And yeah, same the other way around. If A is not bigger than 0 and also not 0, because yeah, we already checked for that there, so it must be smaller than 0. And that means we want to go down, so we subtract 10 by our current altitude. And this we just feed into a PID controller. Where is the PID? I already explained how PID works. You have a measured value and a target value. And we put this into our target value. The measured value is just, again, our current altitude. And what this does right now, I just pressed the up arrow. I just pressed the up arrow once, and this happened. We are at the altitude 134, and because I pressed the up arrow, it added this constant to the output. So now we want to go to altitude 144. But we are at altitude 134. In general, this means when I press the up arrow, as I'm doing right now, we always want to go 10 meters higher than we currently are. This is the entire idea. We just add, right here, we add C and B together. B is the current altitude, C is a constant offset. So we always want to go 10 meters higher. If I press the down arrow, the opposite happens. Then we subtract 10 by the current altitude. You could also add something to the drive, the PID outputs in general, instead of changing the target value for the PID. But right now I can just tap the arrow key, and this will always make me go exactly 10 meters higher. And that's what's kind of great about this. So you can adjust it in steps if you want to. And I really like that, so I did it. And last but not least, we just feed this PID output into a drive. And I did so here. I just we don't need that anymore. I just put this into the drive B, and be careful, you cannot feed it back into the up drive. And this was basically your you cannot feed the signal back into the up drive, because you use it as an input, and then you have a continuous loop. This won't work, so just use any other channel. Soon you're gonna be able to use the custom propulsion channels, and I'm gonna explain that as well, but in a different tutorial. Yeah, right now just keep in mind that I used A for hovering, so all my hover thrusters have A positive in them. So this is basically the new hover channel. And yeah, that's actually it. I did the same for yaw. Let me explain again. Yaw is right here, and they have to do a little bit mathematics. Yeah, I'm not gonna go dig too deep into that, but yeah, basically, again, you have just the input of yaw, also added complex controls, so that's where you can use the complex controller as well, but you really don't need that. So it's just yaw going in the top again. You can basically also ignore that for the moment. So yeah, it's just yaw, which goes into the top again of this mass evaluator, and then you got your current yaw angle, similar to the current altitude in this setup right here. Here you have the altitude, here you have yaw, and again you have a constant offset. This means 10 degrees rotation, and we have the same code in the mass evaluator. It keeps its value when you don't want to change your angle, and it outputs that saved angle into a PID. And yeah, then I output this drive of the PID into the B channel. So all of my yaw thrusters have B. I have the B setting in them. That's the B channel right here. You see, they don't have any yaw setting. They only have B setting. By the way, you can yeah, get those extra channels which aren't used by the game by default by pressing this misc axis. This misc axis tab up there. Yeah, and where is it? There. And yeah, and what I've done right here with this mass evaluator, I'm also going to put this into the description. This is just there to take care of a problem when the angle swaps from minus 180 to plus 180, because yeah, basically if I'm currently looking into the direction 0, so 0 degrees rotation, going in this direction will be a positive angle. So this is plus 90 degrees rotation, and this is plus 180 degrees rotation. And if I go the other way around, this is minus 90 degrees rotation, and this is minus 180 degree rotation. And right here, I swap from minus 180 to plus 180. And the PID, yeah, just think in terms of altitude, only knows linear motion. So if I want to aim into, for example, the direction plus 179, the PID will rotate the craft around, and wants to get to plus 179, but it's very likely to overshoot by 1 degree, and then it's suddenly by minus 180, and the PID is just totally confused and thinks, what, I just increased the value and now I'm back to minus 180. I have to move faster. And again, it tries to increase the angle, so it wants to make the angle more positive. So it goes minus 180, minus 170, minus 90, 0, plus 45, plus 90, plus 179, and suddenly it's back to minus 180. And so it just spins in circles. And to take care of that, I yeah, added this code right here, which takes in as an input the yawing angle at the top and the current target angle at the bottom, and it adjusts the current aiming position for the PID. So if I unfreeze this craft, I can show you what I mean. So I'm now gonna try to aim for minus 180. And you see, I now actually managed to achieve a value which wouldn't even be possible. So the PID normally wouldn't be able to reach this angle anyway, because it doesn't exist in the game. As you see right here, the game says we are at angle 170, and yeah, after this box it actually makes this angle also negative. So yeah, the PID isn't confused anymore. Yeah, and that's basically it. So what you should have learned in this tutorial is how to store stuff into a massive evaluator. I didn't dig too deep into the if statement, but maybe I'll just do that. So the if statement works really simple. It just is if and then two brackets, and then you basically have 3 sections, A, B, and C, divided by commatas. And the A is the question, B will be outputted if the question is positive, and C if the question is negative. So for example, I can ask 1 equals 1, and of course this is true, so it will output B. Let's say B is 10 and C is 100. So right now this outputs 10. Where's the printer? Yeah, 10. And if the statement isn't true, for example 1 equals 2, then it will output 100, because 100 is in the third section of the statement, in the C section, which is the false statement. Not false statement. This is the false case output, and this is the true case output. Yeah, this is just what I used here. So again, you know what? I'm just gonna put this breadboard as a prefab into. I'll upload it on Google Drive, and you can download that if you want to. I'm just gonna upload this on the workshop, and put a workshop link down below, so you can just download this this breadboard, from the workshop. And this is basically it. I also have this gyro stabilized seat in the back there, but I'm gonna do another tutorial about that. So thanks for watching. Soon coming up is this, if you're interested in Lua. This is a PID programmed in Lua, and also custom access. So the idea behind that, a little bit pre-sharing, is to compensate my forward and sideward movement. So if the main drive is 0, this craft will try to don't move forward or backward. And also, I know this from different games, for example Avorion, or different, in general games where you have flying crafts. Avorion, it's spaceships. If you turn in one direction, you're always gonna strafe a little bit. And I wanted to compensate that, so if I now turn left, the code will stop me from strafing. So I'm always gonna fly straight forward. This is gonna be perfectly working in the future, but not right now. So much about that. Yeah, thanks for watching, and see you in the next video, and feel free to ask any questions in the comment section or on the workshop page. Thanks for watching, and bye.